Okay, we're going to be doing the reactions rate lab, and this is chapter 5.9 lab, and we just had a lecture on reaction rates, and what we're going to be looking at is temperature. So we're going to have cold water in here, hot water in here, room temperature water here, and the very last one is going to be a comparison of two room temperatures. What I have in here is an Alka-Seltzer, and in this one I have a crushed Alka-Seltzer. So in this case, we're going to be comparing the size of the particles, one giant particle versus all these tiny particles that are crushed. So you can imagine from the lecture which of these reactions should take place faster. You can predict that based upon the information that we learned in the lecture. Also, you can probably predict which of these are going to be reacting faster based upon the lecture. So right now you should make a prediction of these two, which are going to react faster, and of these two, which are going to react faster as well. So I've already done the whole setup for us. What we do need to do is record the temperatures. So I'm going to pour in 100 milliliters of water in each of these samples, and we'll go ahead and we're going to record. So there's 100 there. There's already 100 milliliters of water that's been heating. And in there is last two contain room temperature waters. So we'll take those temperatures as well. We'll start with the room temperature ones. And this one right here is 20 degrees Celsius. We actually won't need the room temperature for recording that. But you'll notice that in your chart over here, it should be recorded already that room temperature water is 20 degrees Celsius, which it is. So the cold water has dropped down to about 9 degrees Celsius. So if you can record 9 in your chart. The hot water is at about 62 degrees Celsius. So if you can record that information in your chart as well. We'll summarize this in the next video as well. So now we have all of the information. We have a beaker filled with ice. We have Alka-Seltzers that have been cut. The Alka-Seltzers that have been cut in smaller pieces in half. And then we're going to be dropping the Alka-Seltzer in. We're going to be recording the time for these things. So I have a timer right here. We're just going to record the amount of time that it takes for this reaction to take place. So in goes the cold. Let's see, 3, 2, 1, go. Okay, Alka-Seltzer goes in, and it's beginning to bubble. If you want, you can go ahead and fast forward this portion until it looks like it's all dissolved. Okay, so the bubbles are slowing down and it looks like it's pretty much dissolved. And we have 1 minute and 44 seconds for the cold water. So I'm going to record that as 1 minute and 44 over here on our sheets that we have right here. So again, we'll summarize that later. So how fast is it going to take place in the hot water? So we're going to reset our timer. We're going to start it and then drop it in the hot. Okay, you should notice the reaction is much more vigorous. Okay, it's done. It's about 17 seconds, 18 seconds if I'm rounding. Okay, this again showing that the hotter the temperatures, the faster the reactions are going to take place, and that's because the molecules are moving faster. Well, let's now compare these two. We're going to have, they're both at room temperature, and I'm going to take the thermometers out. Getting the timer here going, we're going to see, so what's the time of this going to be? Well, the temperature of this is in between the hot and the cold, so the time should be somewhere in between the hot and the cold. So we'll go ahead and we'll drop this in. So the hot was 18 seconds. The cold was 1 minute and 44 seconds. So it should be somewhere in between those two readings. Almost dissolved. There's still a couple pieces. They're beginning to break up. Okay, and that's about it. So it's 48 seconds. Okay, so what's going to happen when this crushed goes into the water? It's going to be faster or slower? There's smaller pieces, so there's more surface for them to react with the water. Okay, it's pretty much dissolved. There it goes. So that's about 16 seconds being crushed. Faster than the hot. So now we're going to do an analysis of these numbers, and we're going to do some graphing as well.